Okay, section 2 of chapter 3, graphing f of x equals ax squared plus c. This is day 2 of section 2's lesson. Yesterday in our notes we covered these first 2 examples and basically just introed this concept of an ax squared plus c type of quadratic. So just a little bit of background review, stuff that came from yesterday, just a couple of quick pointers, as well as something that came up in section 1. So first off, we're still dealing with quadratics, graphing quadratics. That's the name of this unit. This is pretty much what get used to seeing this at the very beginning of all your sections. We're going to be dealing with lots of different graphs, and we're going to slowly roll out different kinds of twists and turns to different types of quadratics, but they'll all have this in common, x squared, okay? X squared. And so in this case, this is a quadratic, and because it's an x squared graph, I know automatically it's either going to be that happy face U or that sad face U. All right, both these examples are happy face U's, but because it's x squared, I know it's going to have that general shape. Okay, again, as I've mentioned in previous chapters, when we come across other kinds of functions, it's valuable to know just kind of generally what kind of shape you're going to be dealing with, because that's kind of like a quick mental way to check your results. And the spoiler alert here for this entire chapter is we're going to be dealing with x squared parabolas, quadratics. Those are all kind of the same, that U shape, right? In section 1, we learned what this coefficient, this a, what it does to that shape of that parabola, that quadratic, that U shape. The a affects it in 2 ways. So this again came from section 1. So the first way that a affects the shape of this quadratic is it affects the steepness of that U shape. In other words, how tight is that U? Is it going to be wide or is it going to be really narrow? Okay, A affects the steepness. Basically, the bigger that A is, kind of like the slope of a line, the steeper that U shape is going to be. The more narrow, whatever term works for you. Okay, the closer to 0 that A becomes, so like decimals, fractions, whatever it might be, the closer to 0 that A becomes, the wider that parabola gets, the more shallow. Okay, and then the second way that A affects the shape of that quadratic is it's either going to make it happy face or sad face. Basically, it's either going to be an upward opening U shape if A is positive, regardless of what number it is, or it could be a sad face downward opening parabola if A is negative, again, regardless of what number it is. So those are the 2 ways that A affects the shape of the parabola. But in this section, in section 2, we're now adding in a new term. We're either adding or subtracting some number after the x squared, okay? And so we learned in this section what the c does. And the spoiler alert here, and what we kind of explored in these examples, was that c basically takes that quadratic, that parabola, that U shape, and it's either going to move it up or down, however many units that may be, okay? And so in this case, right, this is either going to be, this is what we would call a vertical shift, right? Basically, it's vertically going to move something either up or down. And so in these 2 examples we looked at, all right, well, what happens if I add a number on the outside? It's going to move up that many. So you can see, like in our section 1, our vertex was always on 0, 0, the origin. And in this case, it's like we took that x squared graph, what normally would have been just x squared, and then we add 2. It takes what would have been the vertex and moves it up 2 units. And respectively, we would have found that any coordinate point on the original x squared graph would move up 2 units after the fact. And so basically, it takes the entire U shape and it just shifts it up that many units. And that's if it's added. What we see here is if it's subtracted, then it just does the same thing, but it moves it down. Okay. So the long and the short of it is this, that this plus c is a vertical shift. It takes whatever parabola I had here with the ax squared, and A still affects it the same ways. It affects the steepness and the how it opens up, basically how that U shape opens up, whether it opens up or opens down. Okay, but it takes that shape and then it just shifts it up or down depending on whether you're adding or subtracting here. So for instance, in this first example that we covered yesterday, the -3 here took the x squared parabola and moved it down 3 units. Okay. In this one here, it took the 4x squared graph, which in our section 1 notes would have made this a slightly steeper type of parabola and also upward opening, right? It took that same parabola and it moved it up 1 unit because of the +1, okay? And so we did those examples yesterday. I'm not going to go too deep into those right now. And then we also learned about zeros of a function, right? Zeros of a function, you're going to be asked a couple of problems about these. It's going to ask you to identify them. Again, just be aware that zeros of a function are when the actual function equals 0. In other words, when y equals 0. So this actually goes back to what we did in the previous chapter. So if my function equals 0, I'm literally solving for the polynomial, right? Or graphically, visually, it also means that I'm looking for x-intercepts. In other words, where it crosses the x-axis, whichever that may be. Okay, but for today, we're going to be doing one more example, and that's this one down here. And this is really just going to be pretty brief because it's a pretty simple concept when you compare it to like what we're talking about within this section. It's going to be a repeat of the same concept, but we're ultimately going to be dealing with vertical shifts. But there are a couple of terms here I wanted to kind of point out. So first off, let's just jump right into the example. Here we're given some function. Okay, we're told that this function is -1/2 x squared plus 2. Okay, so the immediate thing to understand is that regardless of what I'm given as a function, the thing I want you to understand is that this equation is going to represent something graphically. I can graph this, right? There's some visualization that this represents. What will it look like? Well, there's quite a bit of information given here. First off, the fact that we're dealing with an x squared, which is no surprise in this chapter, but the x squared tells me I'm going to be dealing with the parabola, okay, that U shape, right? And now other information I can pull out just from this equation, this like what we pulled out of section 1. In section 1, this coefficient is a, the -1/2. And that a tells me a couple of things about the shape of this parabola. First off, the fact that it's 1/2, it's pretty close to 0, is actually going to widen the shape of this U, this parabola. Okay, so the steepness that's actually pretty shallow. 1/2 is pretty close to 0. The next thing is that it's negative. Well, the negative means that it's going to open downward, right? It's a sad face parabola, right? And I just got that from that a out in front multiplied by the x squared. And the next thing is that this +2, this is really from this section. This +2 means that I'm taking what would have been at 0, 0, the vertex, and I'm moving it up 2 units. Okay, so it took that sad face, shallow parabola, and it moved it up 2 units. Okay, none of that's really asked here in the question, but it's kind of useful to break that down looking at this equation. But anyway, we're given this quadratic, this parabola, whatever it may look like on a coordinate grid. And then we're told some other function this is what we would call a transformation. Okay, transformations are something that we dealt with in Math 1. Transformations, essentially, if you need to like write your little notes in the margins and stuff, transformation, simply put, means a change or a movement, right? Basically, what's happening here in this example is this. Here's the shape of a parabola, whatever that may look like. This is a parabola if I were to graph it. This transformation is moving it somehow. And you're going to get asked 2 questions about this. First off, how is this transformation actually changing it? Where is it being moved? And then secondly, we're going to be asked to rewrite this function in terms of that transformation so that that movement, that change can be represented by its own formula. Okay. And that may seem like a lot of complicated things, but really each of the responses is going to be really, really quick and fast. So let me just go ahead and jump right to the punchline about what you're looking for. Part A, describe the transformation from the graph of F. I color coordinated on purpose. From the graph of F, this orange one, to G, this purple, the change basically. Describe how it's changing. That's basically what it's saying. I have some graph, whatever that may look like. That's its own thing. This transformation is changing it somehow. How is it changing? That's what it's asking. And the answer is actually kind of simple. Okay. In this transformation, g of x represents whatever it's changing into. F of x is still the same thing. It's taking like this represents some shape on the coordinate grid. That's what that f of x is. It's going to be some shape on the coordinate grid. And then it's subtracting 7. Well, simply put, it's just doing this, what we talked about at the beginning of the lesson, right? This plus c tells me how it's moving vertically. How is it moving vertically? So if I'm adding some number here, it's moving up that many. If I'm subtracting some number, it's moving down that many. So in short, here in this example, how is this transformation right here? How is it affecting change to the graph of f? It's subtracting 7. So in other words, simply put, I'm moving whatever this may look like. I'm moving that graph down 7. Regardless of whatever shape is here, when I subtract 7 after the fact, I'm taking the whole thing and I'm shifting it down 7 units. So part A, you'll get a couple of questions like this. It'll tell you some transformation, and then it'll be like, all right, well, how is it being changed? You're basically just looking at whatever number's over here. If it's adding 7, you would have said it's moving up 7 units. Since it's subtracting here, then it's moving down 7 units. And then it's however many units the number is right there. Okay, so part A is really quick. You're just saying like, well, this one moves down 7 units because it's subtracting 7, right? Part B says write an equation that represents G again being the change, the transformation, in terms of X. So in other words, what it's saying is like, all right, rewrite this guy, this transformation equation in terms of like X. In other words, it's saying give it its own equation. And what you would do there is because f of x equals this mess right here, this negative 1/2 x squared plus 2, because f of x equals that, I can actually substitute or replace that f of x with its actual equation. Why would I do that? Because now when I subtract 7 from that equation, I can actually combine like terms, and I'll end up with that formula, basically that equation that it's asking me for. And so let me jump to the solutions really quickly just so you can kind of see that worked out. Okay, so here's our last example right here. Again, we're given this quadratic equation. I know it's a quadratic because it's x squared, and we're told that it has this change affected on it, right? And so this minus 7 again, because of that minus 7, that's telling me that's subtracting 7. In other words, it's moving down 7 units. Whatever the hell this orange function may look like, I'm moving it down 7 units. That's what that transformation is doing. And then part B, write an equation that represents it. Here's just the work showing that. This, again, is the equation of our transformation, comparing the two functions. Okay, how would I rewrite that in terms of an actual equation that looks more like that? F of x, since it equals that equation, I'm going to replace the f of x or substitute the f of x with this crazy half of the equation. And then when I subtract 7, this essentially is just combining like terms. X squared can only go with other x squareds. Numbers can only go with other numbers. So this positive 2 and negative 7 right here can combine to make negative 5. And there is my equation. So write an equation that represents the transformation. This would be the actual graph of where it moved to. So let me explain that a little bit more clearly. Again, this equation right here represents some quadratic, some parabola on the coordinate grid, whatever it may look like. This represents where it gets moved to. Well, this movement where it ends up, like if I were to take this parabola and move it down 7 units, this equation represents me just graphing that down 7 unit parabola. Okay, so that's what that represents. But anyway, that's how you would go through it. And that concludes our section 2 notes. Let me go ahead and stop recording.